All right, guys, I found the mistake. This is a typo, so we're gonna just cross this part out here. And this is supposed to say that f of x is the square root of x times g of x. There we go. So g, we don't know what it is, but g of 4 is 2, and g prime of 4 is 3. Now, h is root x, and h prime is 1 over 2 root x, which means h of 4 is also 2, and h prime of 4 is going to be 1 over 4. So when I go to do the derivative of f, this is going to be g times h prime plus h times g prime, 3. And so this is 1 over 2 plus 6. You can write it as 6.5, or you can write it as, oh man, why can't I think of this? 13 over 12? 13 over 2, I mean. Is that right? 6 and 1/2. Yes, there we go. Oh man, I'm having a bit of a day here. Okay, so there is our f prime. So sorry about that. That is a typo. We will do an example like the one here, but that will be in the next section when we do a different rule. So we can use a function that we don't know as long as we are given the value at the point of interest and the derivative at the point of interest, then we can find the point of interest overall. Okay, so that's example 5. Sorry about the confusion, guys. Let's go on to our next rule. This is the quotient rule, rule number 7. This is looking at two functions, f and g, that are differentiable, and we want to find the derivative of a quotient. And here, order matters because we have a minus sign. So it's really important to note that we are looking at denominator, numerator prime, minus numerator, denominator prime, over denominator squared. You can think of it in like alphabetical order. Maybe that'll help you. The denominator d comes before the numerator n. So d regular n prime minus n d prime. However you want to figure out a way to memorize this, you do need to memorize that, but order is really important here. Okay, so again, we're just going to apply this. Remember, these are all shortcuts to doing the full limit definition. We did all the limit definitions in Unit 2. These are just rules to shortcut and bypass all those steps that we used to do to hopefully find the derivatives a lot quicker. So let's take a look at an example here. Here is my numerator. Here is my denominator. So my f prime is going to be denominator, numerator prime, times numerator times denominator prime over denominator squared. So denominator is x squared plus 2x minus 3. Denominator prime, using our power rule from last lesson, is 2x plus 2. Then we have the numerator, which is x cubed plus 1. Numerator prime. Oh my goodness, I have already messed this up. I mislabeled this. So sorry. This is the numerator and numerator prime. This is the denominator, denominator prime, 3x squared. Apologies for that, guys. Okay, f prime. Now remember, it's going to get ugly before it gets pretty, but we are not scared. We are brave, right? So denominator as is, x cubed plus 1 times numerator squared, 2x plus 2 minus numerator as is, x squared, 2x, that's plus there, minus 3, and denominator prime 3x squared all over x cubed plus 1. Okay, this does not look pretty. Let's try expanding, collecting terms, and factoring. This will give me 2x4 plus 2x cubed plus 2x plus 2 minus 3x to the 4 minus 6x to the 3 plus 9x to the 2 all over, oops, missed my square there, x cubed plus 1 all squared. Can we collect like terms here? I see a 4 and a 4. I see a 3 and a 3. And I believe those are the only common terms that I can collect. So let's give it a go here. This will be negative x to the 4th minus 4x to the 3 plus 9x plus 2x plus 2 all over x cubed plus 1 all squared. Yeah, that doesn't look like I can factor it anymore, at least not easily, so I am done. Not as cute as we were hoping, but again, still doable and certainly a lot less work than doing it the limits way, right? All right, let's take a look at example 7. Numerator, denominator. Let's make a list. Numerator is root x. Numerator prime is 1 over 2 root x. Denominator is 1 plus 2x. Denominator prime is just a 2. This one might be a little bit simpler today. So f prime is going to be denominator as is 1 plus 2x times the numerator prime 1 over 2 root x minus denominator prime 2 times the numerator as is 2x root, oops, crossed it out there, and then denominator squared. There we go. Can I make this look any better? Let's see. I don't really think it's going to look any cuter, unfortunately. Can I factor it out, maybe? What if I multiplied both sides by 2? Oops. I multiply by 1. Can I make this look any prettier? This would give me 1 plus 2x minus 4x over 2 root x times 1 plus 2x all squared. Okay, it's not necessarily better, but it's a little bit neater. Oops, that should have been a root x down here. Okay. I made it a little bit more compact, but not really by a whole lot. But again, it is a lot simpler than doing it the old way. There we go. That is our derivative. You could also rationalize the denominator if you need to. It's not really asking us to do anything beyond finding the derivative, so we really don't need to muck around at all. If you had stopped here, that would have been sufficient. The reason I always like to see if there's ways I can simplify collect terms is because I know further down the road when we start doing applications and word problems, it's just easier to deal with a cleaner, simpler derivative than doing something that hasn't been cleaned up, right? So just some tips on here. All right, let's do one more here. Find the equation of the tangent line. Okay, so this is where we're looking for y equals mx plus b. And this is our curve, f of x, and this is our point of interest. So we want f prime at the point 1, right? Okay, let's take a look. First, we need to find our m, which means we need to find our derivative. So again, my numerator is e to the x. My numerator prime is e to the x. My denominator is 1 plus x squared. My denominator prime is just 2x. So my derivative, f prime, is my denominator as is numerator prime minus numerator as is times denominator prime all over denominator squared. Okay, now I need to evaluate this at f prime of 1. So 1 plus 1 squared is 2 times e to the power 1 is just e, minus e to the power 1 is e, 2 times 1 is 2, so 2e all over 1 plus 1 is 2, 2 squared is 4. Now I'm just going to double check that I did this correct. This is a horizontal line, 0. So if that is the case, then my equation of the line is y equals e over 2, right? So this is my point slope form. Y equals mx minus x naught plus y naught, right? If m is 0, this whole piece is 0. So my y-intercept is just e over 2. And I'm just going to double check my work to make sure that I did that correctly. E to the x. Yes. Looks good. All right. Well, that was easy, right? This would be worthy to note. I would maybe put this on a note card that you can use as a bookmark for your formulas. So as you do your homework, you don't have to keep flipping through your notebook if you don't have these memorized. You can just use your note card to help you do your homework. Also really helpful when you're doing a study guide or when you are practicing for a quiz or a test or anything like that. I'm hoping that these ones are easy enough for you to memorize. You don't actually have to write them down. These ones I would highly recommend that you either commit to memory or carry around a little note card that has them on there in case as you study so that you get lots of practice with them. All right, good luck, guys.